Continuing on redox for MCQ 21. This question asks about the process of disproportion whereby a substance, or in this case, an element is both oxidized and reduced at the same time. I would have again advised for you to go with SHOE and to use S as a primary indicator of process or an element going through oxidation or reduction, and that is once again using oxidation state as a basis for comparison. So for each of the equation, we need to write it out and find out the individual oxidation state. Now for the case of A, we're going to have 3 units of copper plus 8 nitric acid to give us copper nitrate plus 2 nitrogen monoxide plus 4 units of water itself. Copper is an element, oxidation state of 0. Hydrogen will hold that of a +1. Each of the oxygen is -2. So in the determination for nitrogen, we'll have a +1 and X and a 3 times -2. All of them add up together because it's a neutral molecule to give us 0. X will come in at the value of a +6 -1 or a +5. Now on the right hand side for the product, copper will be holding a charge of +2, oxygen will be that of a -2. So if you were to extract copper nitrate, the nitrate out, NO3 minus, we know that this is a 3 times a -2 and an unknown nitrogen, and it has a charge of negative, so this is equals to -1, and X is equals to -1 plus 6, which is equals to that of a +5 for my nitrogen. Oxygen here will be a -2, nitrogen here will be a +2, and water, oxygen is a -2, and hydrogen is a +1 each. Now in this case of comparison, for copper, I'm going to go from 0 to +2. This is an oxidation process, but I do not see copper going through a reduction process. Now in the comparison for nitrogen, it has went from +5, but it maintains its oxidation at that of +5. So for A itself, we are definitely looking for nitrogen not going through any process when it converts to copper nitrate. But if you compare to that in nitrogen monoxide, it went from a +5 to a +2. So it has been reduced. But none of the elements above mentioned has go through oxidation and reduction simultaneously. So now let's try it out for part B. A moment while I will erase the slate over here. So for part B, we're going to get chlorine plus 2 units of sodium hydroxide to give us NaCl plus NaOCl plus H2O. Write out the oxidation state. Chlorine is an element, 0, sodium that of +1, hydrogen +1, and oxygen is -2. Sodium chloride +1, chlorine -1, Na +1, oxygen -2, chlorine here would have to be a +1, oxygen of a -2, and hydrogen of a +1 each. Now the comparison here, we'll see that chlorine went from 0 to that of a -1, so I am looking at a reduction process. And if I were to change side and take a look at that from a 0 towards that of a +1, this could have been seen as an oxidation process. So I'll say that the answer for this question here would have actually been B by itself, because chlorine went through both oxidation and reduction at the same time. Now let's investigate the rest of the equation to see that why they couldn't have been the answer here. So for part C, we're looking at iron 3 sulfate plus potassium iodide to give us iron 2 sulfate, potassium sulfate, as well as iodine. Now doing the individual oxidation state, this will be a +3. Oxygen will be a -2. Same thing for sulfur. We will extract this thing out, treating it as SO4 2-. 4 of -2 for oxygen, a single X to represent the unknown for sulfur, which should have been all equals to -2. X will be equals to -2 plus 8 to give us an oxidation state of +6. Potassium of a +1 since it's group 1, iodine of a -1 since it's group 7. Now we do see that iron drop down to that of a +2. Oxygen will be still coming at -2. The sulfur here will still have an oxidation state of +6. Potassium +1, +6 for sulfur, -2 for oxygen, and then 0 for chlorine. Now doing the act of comparison, iodine went from a -1 to a 0. This itself is considered to be an oxidation process. Now for the case for iron, it went from a +3 to a +2. This is a reduction event, but none of the elements actually go through oxidation and reduction at the same time. Now the final comparison here for D. We're going to have lead-2 nitrate becoming lead-2 oxide plus 4 nitrogen dioxide plus oxygen. Writing out the oxidation state, I have a +2 for lead, -2 for oxygen. Again, treating the whole NO3 minus 3 times -2 X to represent the oxidation state of nitrogen. And this is equals to -1. X would have been -1 plus 6. Going to go with a +5 over here. Lead-2 stays as +2. Oxygen that of -2. -2. Nitrogen of that of a +4. And elemental oxygen going at 0. And doing a comparison here, you can see that lead did not have any change in the oxidation state. But oxygen in the nitrate did went from a -2 to a 0. This is an oxidation event that's happening. And for the case of nitrogen, it went from a +5 to a +4. This is a reduction event that's happening. So all in all, coming back, the correct answer for this question would have been B, as chlorine went through a disproportion reaction by going through oxidation and reduction at the same time.